All right, let's go over stats quiz number 4, October 21st, 2020. Question number 1. Bryson collects data on the depth of a river at various points and the velocity of the river at these points. His data has a correlation coefficient of negative. I'm going to highlight this. Correlation coefficient of negative 0.9382, which could represent Bryson's data. Okay, a couple things I noticed right away. This is a negative correlation. And then this number is close to 1, so I would say this is a strong one. So if I go through each of these, this one is negative. I'm kind of try to put a line through it. I think that one's pretty strong. That's a good choice on this one. This one over here looks to be positive, and that would be strong. But because it's positive, I would not choose that one. This one looks to be no correlation. And this one looks to be positive, but weak, because they're kind of far away from the line. So then your correct answer is A. Let's go to question number B, or question number 2, part A, age of parents. Consider the scatter plot. Okay, so I noticed that the x-axis, or the explanatory, is the x, and then on the y-axis you have the response, or the results. And it looks like I have here a positive, and it looks to be a strong correlation. Strong to moderate. Which statements select all the statements? Hopefully I pointed out to you that this is plural, so there could be more than one that describe this scatter plot. Okay, we said that it's positive, it's not negative, so check means yes, X means no. The scatter plot has no correlation. No, I think it does. The scatter plot shows a strong correlation. I think it does. The scatter plot shows a moderate correlation. Okay, so how can you distinguish the two? I definitely see a lot of points on the line that I drew, or any line that you can possibly draw. So I would say this would be a strong and not moderate. So my answers are A and D. Okay, same graph about the parents. Choose the best answer. So this is only one answer. The ages of parents do not show causation. So the question, does the X cause the Y? Whoops. Does the X cause the Y, or the Y cause the X? You have choice A, association is never causation. That is true. We cannot use the mother's age to accurately predict the father's age. We haven't talked about predicting yet, but no. We were not giving a data table. Well, we have the order of pairs, you can create one, but that's not it, and this is not a function, not important. The answer is A. I think we wrote that multiple times in our notes. Just because you have a strong, let me write another word here. Just because you have a strong association or correlation does not mean it explains the causation, or if it causes it. Okay, all you can say is it just has a strong correlation or association. Question number 3. Which of the following could describe a scenario with an explanatory, so that's my x, and response variable, which is my y? Select all that apply because it can be multiple. Okay, the amount of money Mike earned for chores and the money he spent on lunch. Could you, if you made a lot of money, could you spend a lot of money on lunch? Yes. The total amount of money Mike earned on chores, and then could you also measure, or could that explain the total amount of money Mike has? Yes. If you make more money, then you have more money. A is kind of like you have more money, you can spend more money. C, the total of green marbles and the total number of blue marbles Julia has. Does it kind of give you more details about Julia? She can only have 10 marbles, or she's only limited? No, it doesn't. So the green should not affect the blue, and the blue does not affect the green. So this would be a no. D, the total number of candies in a bag and the number of candies eaten. Yes, that'd be true if you can tell how many are in the bag. So if I give my kids a lot of candies in the bag, let's just say there's 100 of them, and maybe I say don't eat any, and they have 0, and then I can measure it, right? Maybe there's 95 in the bag, and I can assume that they ate 5 of them. Okay, so that would be a yes. So my answers would be A, B, and D. The linear model shows the relationship between the number of grocery items purchased and the total cost of the grocery bill has a correlation coefficient. Remember, we've talked about in class, that's basically an R value of 0.97. Which statement of the variables is true? Which statement is singular, so there's only be one answer. Okay, so this is the one where you have to practice drawing our pictures. Okay, the relationship between the number of grocery items, I don't know, this helps me just to draw, so I get a visual, right? 0, 1, 2, 3. And then over here you have total cost of grocery bill. So total cost, and that's measured in dollars, right? So you have something like 0, 1, 2, 3. Okay, so they're saying that the correlation coefficient is positive and very close to 0.97. So all those dots are super close to that line. Okay, now with this visual, let's see if we can answer these questions. Purchasing more items. So as I go towards the right, let's get a different color here. Purchasing more items. So that's the x-axis. So as I go up, what's happening as I go in this direction? Does my total cost go up? Yes, it does. That is a true statement. I'm trying to look for trues here. Wait, let me get rid of those blue lines first. True statement. Okay, let's try another one. If the grocery bill has a lower cost, so something like down here, try to get a different color, something down here, then the more items that have been purchased. That is possible, but it seems like it's far away. It's rare to get a lot of items and cost a little, right? Maybe you're buying, like, I don't know, 2 grains of rice or 2 grains of beans, or 1 strawberry, right? That's pretty unlikely. There is no relationship between the number of items purchased and the total cost. This one's saying no correlation. But we just said that there is a correlation coefficient of 0.97, so that's not right. And then there's a strong relationship between the number of items purchased and the total cost. Strong, yes. We're at 0.97. Okay, I'm between A and D. Let's go back to A. Purchasing more items. Here's the key word. Causes. Causes. Association, just because there's association between item numbers and total cost does not mean it causes that, because this example is actually a good one. The other example, we talked about how you can buy like a bunch of items and cost less. That's hard. Or let's just say you buy one item, maybe you buy something really expensive like wine or some imported cheese from a foreign country and it costs a lot, but you only have one item. That would go against your linear relationship. So the correct answer is going to be D. For the answer is D. Why? Because for A, correlation or association does not mean causation. One does not cause the other. Okay, there's a strong correlation, we would say, unless we can prove it, which we're actually going to try to prove it in the next couple of chapters. Question number 5. A linear model shows a relationship between the number of unexcused absences. I'm just going to unexcused absences. Okay, so unexcused absences are you don't show up to class and you don't have a valid excuse. 0, 2, 4, right? Number of absence of days. And then what's the other part? And GPA. I don't know, you would hope you would have a GPA of 4.0, which is like an A, right? And it has a correlation coefficient of negative 0.87. Okay, so negative is going like this. Okay, which statement about the variables is true? And it tells us choose all that are true. Okay. Increased unexcused absences, so I like to say as I go towards the right, causes a higher, did the graph go up? The answer is no, it did not go up. That's false, we're looking for true. Increased unexcused absences, okay, let's try that again. Increase as you go from 0 unexcused, 1, 2, 3, 4 unexcused, then you have a lower GPA. What's happening to the graph? Is it going down? That is true. Uh-oh, we did it again. Got my mistake, look. So the answer for that one is no. Association does not imply causation. No. Just because of those two words, guys. Or one word, causes. If there is a correlation or an association, it does not mean causation, or one causes the other. Okay? So look at C. There is a strong, this number is strong, right? It's closer to 1. It's negative, yes. Between unexcused absences and grade point average, yes. D, there is no correlation. Well, this would be a number that's closer to 0, in which we have either a number closer to -1 or +1, so our answer is going to be C. 5, the correct answer is C. Number 6, which of the following correlation coefficients indicates the greatest correlation between two variables? Remember, correlation is a measure of strength. We talked about how on that scale it's -1 to +1, and 0 means no correlation. So this would be a positive, this would be a negative, this is strong, strong, and then if you get into numbers like, I don't know, 0.5, -0.5, this would be moderately negative. This would be moderate positive, and then like 0.2, -0.2 in this case would be weak. 0.2, because it's closer to 0. Okay, so which one of these has the strongest numbers, meaning in the purple, And that would be D. Number 6, the answer is D. And a time plot. Why do I see a time plot? Because it has time. So these called time. That's my T. Come on, Mr. T-I-M-E-P-L-O-T. Time plot. The scatter plot, or this is specifically a time plot because it's measuring time, shows a relation between Marvin's age, there's my time, and the time it took him to run a mile. Well, I noticed there's a negative strong correlation because those numbers are pretty much on the line, or say association. Let's be careful of the word cause. All right, let's do this one. As Marvin's age increases, so as I go towards the right, the time it took him to run a mile increased. Is the graph going up? No, it's decreasing. So, no, it should be decreasing. Yes. As you're going to left to right, is the graph increasing or decreasing? It's decreasing. Oh, sorry. Which statement best describes? So which statement is 1? As Marvin's age increased, right, as I go in this direction, the time it took him to run the mile remains constant. So does it remain like flat? Does it go like that? No, it doesn't. And then the last one, there is no relationship between Marvin's age and the time it took. Remember, no relationship basically means R is 0, but that's not the case. So the correct answer is B. 7 is B. Hopefully that was helpful. See you guys.